Hello and welcome to this video on anhydrous chemicals. Anhydrous chemicals are by definition chemicals without water. You can think of them as being similar to freeze-dried coffee that you can then dissolve in boiling water to create a tasty beverage. However, we don't suggest making a beverage out of anhydrous chemicals. That's because, well, first of all, most of the time it's not boiling water that is used as a solvent. It would not be necessary to use anhydrous chemicals if you were going to dissolve it in water. Instead, it is other solvents such as alcohols, oils, gases, and more. Other reasons you may want to use anhydrous chemicals is, well, when they undergo a reaction with water, such as hydrolysis. And not having any water in said chemical to start with removes that problem. Another is to use the water-free chemical as a solvent in its own right, such is the case with anhydrous acetone. You will, as a broad rule, find that anhydrous compounds appear as a crystal, just like granules of coffee. In other cases, it may be a gas. Rarely, you will find it as a solid mass, but this is nearly only applicable to metals, which we won't cover any real detail here. The reason many products appear as granules owes to the way they are generated. The common means of creating anhydrous compounds is freeze-drying. To freeze-dry something, you extract it from its source. Then the liquid extract is placed into a container. The contents of said container are frozen and the container put into a vacuum chamber. The chamber is then vacuumed to create a negative pressure. The negative pressure causes the water to sublimate and turn into vapor, which is drawn off and away by the vacuum pump. This is made possible by having a negative pressure or a vacuum environment. That means the vapor temperature required is much lower, allowing you to have a frozen solid substance, but also turn the liquid into a gas. As whatever you're working with is frozen solid, the mass itself will not change, but the water is drawn away without the small amount of whatever your target chemical is. This leaves it behind in the end, ideally with almost or practically no water to speak of. The product is then kept anhydrous by storing it with something like silica gel or other dehydrating or desiccant products. Other means of creating anhydrous chemicals include things like distillation or reacting it with metals. In application, anhydrous chemicals have some, let's say, extremely different properties to their hydrated counterparts. A simple but very clear example is acetone. One of the key properties that makes anhydrous acetone so useful is that it has a very low boiling point, but it also means it's very volatile. If you're working with something like, say, a gas chromatography, this low boiling point or ability to turn into vapor or volatility is extremely useful, not just in terms of its ability to pass through your gas chromatograph, but it also leaves behind practically no sample. This can be useful in the case of destructive testing of samples or surfaces, cleaning surfaces, and similar. Another advantage of it is that because it's anhydrous, it can not only interact with, but become miscible with many organic solvents. This means if you're trying to undergo a chemical reaction or cause a chemical reaction or process, anhydrous acetone is extremely useful, largely due to that reactivity. At the other end of this, though, you do have, well, the safety of anhydrous acetone as an example. Because there is no water within it, it has arguably a greater flammability. Although, to be blunt, it's acetone, it's already quite flammable. This does mean that it needs a certain greater care taken in terms of storage. There's also the problem, and arguably a fairly well-established problem already with acetone, of toxicity. But because anhydrous acetone is more volatile and reactive and more readily turns into a gas, arguably, you have issues around respiratory dangers. Although, to be blunt, you have respiratory dangers anyway, it's just, well, this is more easy to occur. And then finally there is that, as mentioned, reactivity. The biggest problem is going to be both the flammability, but the flammability, once it turns into a gas, becomes a risk of explosion. There's also the issue of toxicity, as mentioned with the respiratory system. And then finally, whatever environment you're working in and with, you need to use appropriate equipment so that reactivity doesn't cause unintended consequences, particularly if the containers you're using for it, for instance, are incompatible. Anhydrous acetone is just one example, and there are many out there, and it all comes down to what you want to use it for. Most of the time, you're using anhydrous products because you want to avoid using water, or you want to ensure that the water content you add is deliberately added. It allows you to very carefully control your reaction almost perfectly. Well, as perfectly as chemistry allows for anyway. Hopefully this has explained what anhydrous is in terms of chemistry and what and why you might use it. Thank you for watching this video. If you have found it useful, consider liking, sharing, and subscribing. Please do post any comments, questions, or suggestions you have below.